The next box has lots of different facts about logarithms. So a logarithm is a function, meaning it has an input and it has an output, and we can graph it. And it's also the inverse of the exponential function. So we kind of touched on this earlier because the exponential function grows really quickly while the logarithmic function grows really slowly. And you may also remember from the section on inverses that graphically a function and its inverse are symmetric about the diagonal line. And we saw that the graphs for the exponentials look like this, and our graphs for the logarithms look like that. So they really are symmetrical. Okay, so also logarithms have implied parentheses. So if you see log of x, that really means the same thing as log of x with parentheses. This x is really the input of the logarithmic function. Log of 3x means the same thing as log of 3x with parentheses. Now this is where we need to be careful, is when you see plus and minus signs, because that really indicates that we have a different term. So log of x plus 3 means log of x, and then the logarithm is done, and then there's just this plus 3 off to the side. So if you want to have an x plus 3 on the inside of the logarithm, then you have to put your own parentheses around it. So let me make a note of that. So if you want the x plus 3 on the inside of the log, meaning that it's the input of the logarithm, then you would have to put log of x plus 3 yourself. You'd have to put your own parentheses, because without parentheses it just means this. So you have to be really careful with that. Okay, so then we have the definition of the logarithmic function. And the definition is that we can have it in this form: log base b of x is equal to y. But we also have an equivalent exponential form. And this is really true for every logarithm. Every logarithm has an equivalent exponential form, and we can convert back and forth between these two. So sometimes it's going to be better to have our equation in logarithmic form. Sometimes it's going to be better to have our equation in exponential form. It's kind of like fractions and decimals. So 0.75 and 3/4. These do not look anything alike. However, they mean exactly the same thing. And you can convert back and forth between the two of them. And sometimes it's better to be in decimal form. Sometimes it's better to be in fraction form. Okay, so b is the base of the exponential and the logarithm. Two other things before we get to the problems. Log of x, if you don't see any number here for the base, it has an implied base of 10. And then ln, which we've also been working with, this has an implied base of e. So log of x, this is really just the same thing as log base 10 of x. ln is log base e of x. So those are some more notations. Okay, so they want us to express the equation in exponential form. So for number 9, I need to transform it. So I'm going to take 3, raise it to the 4, and that's going to be equal to 81. So I'm really just following this conversion right here. So I drop the logarithm and I shift around the numbers, and it's 3 raised to the 4 is equal to 81. And that's our answer. Now, to check your work, this should be a true statement. So if you want to check on your calculator, is 3 raised to the 4 equal to 81? And it is. Okay, so 10, I want to transform it's going to be like that. It's going to be 4 raised to the 0 is equal to 1. And that's our answer. And again, that is a true statement. Anything raised to the 0 power is 1. And lastly, for number 11, I want to transform. So it's 5 raised to negative 1 is equal to 1 over 5. And that is true. Anything raised to the negative 1 power is the reciprocal.